Hey folks, here come the test corrections. Let's see. Problem number one. Let's see here. I want to center this up a little bit better. It's asking for the scale factor, right? We said you got to take the image divided by the pre-image. So that means we got to do 4 divided by 5. Okay, so let's put that down. Scale factor equals image. Come on. Image divided by pre-image. So that means 4 is from the image, 5 is from the pre-image, right? See how I kind of labeled this right here? PQRS is the image. KLMN is the original figure. So we're going from this figure to that figure, a reduction, right? So our scale factor should be less than 1. A football field's 160 by 360 long. It says Abby wants to make a scale drawing so that 1 inch represents 20 feet. So we could set up, in this case, like 1 inch to 20 feet. And then you would have the drawing, like up here, this is what we want to know. We want to know the drawings, dimensions, right? So the drawing is going to go up here, and then the actual football field's down here, 160 feet, right? When you cross multiply, you get 20x equals 160. You divide by 20, and you end up with 8. So 8 inches in that dimension. And you might say, notice what we're doing. We're just taking 20 and we're dividing into 160. So you could take 20 and divide it into 360. That goes in there 18 times. So our other dimension's 18. If you don't like that, you could just set up another scale factor like this. I know I'm using x twice, which might be bad form on my part. So if you made a drawing, that I've been advocating that, and you said, okay, x is going to be the width and y is going to be the length, then maybe you want to change this x right here to a y. And then when you cross multiply, you get 20y equals 360. And then you divide both sides by 20. See how we're taking the dimensions of the football field and we're dividing by 20. All right, so it says a center dilation maps this point to that point. So this is the image over here. This is the pre-image over here. So we take the image divided by the pre-image. You could do either 3 divided by 1 or 9 divided by 3. That's our scale factor, 3 divided by 1. The next one says, hey, how big is EH? EH. If these two figures are similar to each other, probably should have put that right up here, that A, B, C, D is similar to E, F, G, H. The scale factor has to be the same, right? So we're dividing by 2, right, to get down to that side. So if I divide this by 2, right, I'm at 4. All right, so 4 is that one. It says, hey, how big is angle G? Well, G is the third letter. So we've got to match it up with the third letter right over there, C, right? The measure of angle G is equal to the measure of angle C. So where's angle C? 99 degrees. All right. Next one, number 6, says, how do you know those two triangles are similar to each other? Well, because we have a couple pairs of angles here, 61 and 61. We have another couple pair of angles, 64 and 64. So by angle similarity. On this one, we don't have two angles equal to each other. We don't know if this is 45 degrees up here. We do have 52 degrees and 52, and then we have the sides. So 6 to 10, right? What's that ratio? You could write it either way since it didn't tell us which one's the image, which one's the pre-image, but I'll go 10 divided by 6. What the heck? And then I want to see if it's the same as the 6 2/3 and 4 ratio. So I'm going to set that equal to 6 2/3 over 4. And when I cross multiply, hold on one sec here. What did I do here? 10 to 6 and 6 2/3 to 4. Oh, yeah. I'm doing this right. So cross multiply, and 6 times 6 2/3 would be, 36 2/3 of 6 is 4. So 36 plus 4 is 40. And 4 times 10 is 40. So by doing this process right here, we're showing that the proportion is the true proportion, that the ratio on the left equals the ratio on the right. That's what I meant by show the ratios. And so what does that mean? We got a side angle side situation. Pair of sides in a certain ratio, another pair of sides in the same ratio. The included angle is equal to each other, right? This one, I wanted you to mark up the vertical angles as being equal to each other. And then you've got also this angle here marked equal to that one. So this is an angle-angle similarity. Those little angles are kind of hard to see. Sorry about that. Number 9, how do we know these two triangles are similar? This is a side-side-side situation. So I take the smallest side, match it up with the smallest side. So we got 10 to 5, that's 2. I'm going to take the medium side and match it up with the medium side. So 12 divided by 6 is 2. And I'm going to take the largest side and match it up with the largest side. So I've got 14 divided by 7, 2. So check mark, this is a side, side, side situation. I wanted you to show the ratios to get full credit. All right, when you have corresponding angles like this equal to each other, this side's parallel to this one. That means that the top triangle is similar to the whole triangle. So we could set up a ratio like 3 over 5 is equal to 5 over 5 plus x, right? This whole side is 5 long. Most people didn't do it that way because in like the following section, we did a little proof that said the top part to the bottom part, that ratio, 3 to 2, would be equal to the top part to the bottom part, so 5 to x. And this one's just a little bit easier to solve. We get 10, 3x, divide by 3, and you get 3 1/3 for the x. This one is a little bit trickier to solve because you got to remember to distribute the 3 through. So you get 15 plus 3x, right? I got to take this 3 and multiply by 5. I also need to multiply it by the x. That's a distributed property, right? Subtract 15, you get 10 equals 3x. Notice that? Boom, same equation. And so x equals 3 1/3. Number 11, if you have similar triangles, how do we know we have similar triangles here? Well, it should have said that as well. Should have said these two triangles are similar. Sorry about that. All you have to do if you have similar triangles, all their corresponding parts are going to be in the same ratio. So 9 to 12, so you go 9 to 12 is equal to x to 10. X and 10 are the heights of the triangle, right? And so let's see, I'd reduce first. So I get 3/4 is equal to x to 10. And then we're going to cross multiply, right? So we get 30 equals 4x. You divide by 4, and it goes into there 7.5 times. So, guys, the important part about this chapter is that we recognize similar triangles and that we know that we can match up their corresponding parts, right? So like a problem like this is really important that you understand, side, side, side similarity, angle, angle similarity is really important. We're going to use that in chapter 4 a ton, as you saw in section 1, right? All right. Hey, thanks for watching my video. Good luck with the test corrections.